So this is Chemistry 5.2, Acids, Bases and Salts for Foundation Tier paper. So question number 1, sulfuric acid is a strong acid. Tick the box the pH value of sulfuric acid. So if it's a strong acid, it's going to be the closest to 0 you can get, and that is 1. Give the chemical name of an acid other than sulfuric acid. The easiest one to remember is hydrochloric acid. You could have a nitric acid, ethanoic acid, but the easiest one to remember is hydrochloric acid. Name the gas given off when dilute sulfuric acid reacts with sodium carbonate. So as soon as you see the word carbonate, you should be thinking carbon dioxide. The second question then asks you to look at an acid reacting with a dilute sodium hydroxide, so an acid reacting with an alkali. So they've given you the method there, told you exactly what he's done, and then they've asked you to plot the results. So first thing you should be doing is worth 3 marks, a nice easy 3 marks because they've given you the axes. Don't get confused because it's on a different page. Okay, so on the grid opposite, they've given you the axes, so that's why it's only worth 3 marks. So you just plot it, and I've drawn a curve along. Use the graph to find the maximum temperature rise during the experiments. The maximum temperature rise would be the smallest, so the starting temperature or the lowest temperature and the top temperature. Take them away from each other and you get 5.5. The volume of acid needed to neutralise all the alkali, so that's that top point there, that's the neutralisation mark, and in this case it's 50. Question number 3 is a question that comes up quite often. They like these questions. So you are given dilute hydrochloric acid in the middle and certain things are added to it throughout, and you've got to work out what's going on. So dilute hydrochloric acid plus copper carbonate, blue solution A and a colourless glass B. So straight away if you see hydrochloric acid plus copper carbonate, you should be thinking what salt's going to be formed, which will be the blue solution A, and in this case it would be copper chloride. Like I said before, if you see a carbonate, the colourless gas is going to be carbon dioxide. And then you've got hydrochloric acid makes sodium chloride. So you're looking for an alkali that will help you make sodium chloride. So I put sodium oxide. You could have put sodium hydroxide and still got the mark. Moving forward then to the bottom of this question, which is a balancing equation question. Balancing equations is a core topic, but you can be asked it in additional. Balance a simple equation for the reaction between zinc and dilute hydrochloric acid. So I've lined them all up, worked out originally what I had, worked out what I need more of. They've only got 1 box here, so it's a nice easy question. What do you do to make them all the same? Put a 2 in front. That is a nice easy balancing equation question. Really easy, 4 marks there. So the next question again, looking at pH. The following table describes the pH of some common substances. Use only the information from the table to answer parts I and A. So only the information from the table. Don't start making up things. Name the strongest acids. You're looking for the one closest to 0, and in this case it's 2.2, which would be lemon juice. Name the substance closest to being neutral. So neutral is 7, so that one in there is the closest to being neutral, which is saliva. Milk of magnesia is used to treat indigestion. It contains magnesium hydroxide, which reacts with excess hydrochloric acid in the stomach. Complete the following word equation to show the products formed. So magnesium hydroxide plus hydrochloric acid. So straight away, what's the first name of the salt going to be? You're looking for the metal in the alkali, so it'll be magnesium. Then you've got hydrochloric acid. What type of salt do they make? Chlorides. If in doubt, write water. This one is definitely water because you've got hydroxide. Another indigestion remedy contains calcium carbonate. Again, as soon as you see carbonate, what should you be thinking? Carbon dioxide. Name the gas produced when calcium carbonate reacts with hydrochloric acid and state how this gas can be identified. So as soon as you see carbonate, it's going to be carbon dioxide. How do you identify carbon dioxide? Lime water will turn cloudy. So question number 5 again is looking at graphs. So it's a graph question. You've done a titration. You are measuring. How long the temperature rise, or what the temperature rise is during neutralization. The graph shows how the temperature changes when acids A and B are separately added to 25 centimeters cubed of sodium hydroxide. So the volume of acid required. So you've got to first work out the volume of acid required to neutralize the sodium hydroxide in both solutions. So you're looking at this peak. That is the neutralization peak. If you drew a line up, it should go to 25 centimeters cubed. The maximum temperature rise for acid B, so you're looking for the lowest temperature, which is 23.5, top temperature, which is 25, so 25 take away 23.5 gives you 1.5. State which acid A or B is stronger and give a reason for your answer. Acid A, greater temperature rise, produces more heat. Describe how an indicator could be used to find the exact volume of acid needed for neutralization. So add the acid solely from the burette, because that's where your alkali is this time round. Your acid is in the burette. Add the indicator to the sodium hydroxide solution. That really should have gone first. And wait until the indicator changes colour. So as soon as that indicator changes colour, you will know that neutralization has taken place. This kind of question comes up an awful lot. So how do you make copper sulfate crystals, or how do you make a certain type of crystals? The unlabeled diagram below shows 2 of the 3 stages involved. Describe, so say what you would see, the preparation of copper sulfate crystals by this method, and including your answer what you would expect to see at each stage. So this is stage number 1. Add the copper carbonate to the sulfuric acid in the beaker. You could have written to measure it out if you wanted to. You use the stirrer to mix the mixture. You should see fizzing and a temperature increase. When the reaction is finished, you will see some copper carbonate left at the bottom. That's when you know the reaction is finished. Moving on then to the second part, you have to filter the copper sulfate using the funnel to remove the excess copper carbonate. So any excess that was left to show you the reaction is finished will then be filtered and removed. You should then put it in an evaporating basin. So you should see a blue solution by here, and then the excess copper carbonate in the filter paper. The crystals will be formed by the evaporation in the evaporating basin. This may require heat. It will remove any water, so you're left just with your copper sulfate crystals. And then I've just done an equation for you. Copper carbonate plus sulfuric acid goes to copper sulfate plus carbon dioxide plus water.